In this video, we want to explore development frameworks for subsystems, units, etc. In aerospace systems. We'll review the learning outcomes, and we'll review what we did in the last lecture about aerospace systems lifecycle. And then we'll talk about some development frameworks, including plan development, and then some Agile. So when we get done with this module, you should be able to list the stages of aerospace systems lifecycle. You should be able to tell the difference between validation and verification. You should be able to talk about the differences between engineering development processes. So the aerospace systems lifecycle in our framework, we said included conceptualization, which actually comes before design in this diagram here, then design, then development, production, use, operations, support and maintenance, and then disposal and decommissioning. So we talked about system decomposition. So as we go from left to right in this diagram, we're talking about decomposing the aircraft into subsystems and then decomposing the subsystems into subsystems until you finally get to the lowest case, which would be called units here. At every level, you can talk about requirements. These are shall statements that the system or subsystem or unit has to implement. Requirements are validated, and the validation question is really, is this the right thing to be doing? Is the system, the subsystem, the unit doing the right? Is it doing the right thing for the system? Are we building the right product? As we implement the system, going further to smaller levels, then we actually implement the hardware and software at the lowest level. This is V in this diagram, and then we work our way back up. Then we have to test the what's been developed, test it as it gets integrated back up. That's the verification process. And verification asks, is the system, the subsystem, the unit doing the right thing? Is it working right? So validation asks, are we building the right thing? And then verification asks, have we built it right? Have we done what we were supposed to do? In civil aviation, V&V are supposed to be done by an independent unit of the organization. It's less strict in military development. So when we get down to this bottom here in this diagram, how do we do the software development? How do we do the hardware development? And in some cases, this applies to the whole system. The implementation strategy we're going to talk about here is called plan development, and it's also known as linear sequential, and it's also known as waterfall, because you can sort of see here, we've sort of, this is very similar to what we talked about the stages of the aerospace systems life cycle. It's done in stages. You do the requirements first, and you presume you can identify all the system requirements and get that done completely and validate those requirements. And then go and do your design. And so once you've got your requirements, you go and do your design. And then once you've got your design, then you go and do your implementation of the design, your build. Then once you've got it built, you can do the testing and do verification. And then you do, once it's operational, then you can do the maintenance on it. This image itself comes from software where you just mainly go from verification into service and then it goes into maintenance. But on a larger aerospace system, you have the same kind of framework. The advantages are this is simple, it's structured, the milestones are clear, you get the requirements finished, you get the design finished, you get the implementation finished. The disadvantages are it can't, nothing is actually produced until late in the process. I mean, you spend your time doing your requirements and you do your design and then your implementation before you finally get anything you can test to see. So if the requirements changed, if the customer changed their mind, or if you learned things as you went along that would have improved the product, those aren't necessarily captured in the requirements. So it doesn't handle changing requirements well. And changing requirements is just a fact of life in many systems. There's a case study of the FBI wanted to build a system to take their agent data from local offices and put that into a database that would be shared by agencies everywhere. This is pre 9/11. And it was, I think, probably 9/11 is what actually motivated the change, where they were going to build this system that would enable the paperwork would be done through the computer. I mean, this is back in the time when they did things in carbon copies and the like. So they're trying to move this system to a more computerized system and a more integrated system from what they had, their initial computerized system. And every time a new manager would touch this thing they were talking about building, they want a new feature added. So the requirements kept changing and changing and changing. The cost overruns just blew up. They never got it built at all. they had to go back and just do a restart of the whole thing. And when they did, they went to this agile processes that we can talk about in a minute. Variants on the plan development approach or the spiral model. In this sense, you start and you go through phases, and in the phases, I mean, these phases take a good time here. So, I mean, just like in the waterfall model, where you spend a lot of time doing requirements and a lot of time doing design, then you spend your time doing development. Here, you spend time working on concepts, concepts of the requirements, concepts of operation. Where you work outward from the inside of the circle here at the combination of the axes. Uh, and so you know, then so you go through these phases, and the first phase is you end in each phase you try to determine what your objectives are, identify the risk, and then do some development tests, maybe build a prototype, and then plan what you're going to do next. So again, this one starts actually, I started at the wrong place. You start with the requirements plan, and then you do a risk analysis based on that. Get your concept of requirements, concept of your requirements plan. I guess I just started. Then you do your risk analysis, get your first prototype, and then you develop requirements, do your V&V validation on those using the prototype, and then you come up with a development plan, work out again, do a risk analysis, get another prototype, again, do another validation verification stuff. Then you get a test plan, you get an operational prototype. And so you just work in sort of cycles between determining the objectives of the cycle, the risks that are involved, and resolve those. Then you do your development test, and then you plan what you're going to do next. The iterations here happen on a time scale of, say, maybe multiple months, years. These are not short time scales in between. Here's one we've actually already seen. It's called the V model, and it's really waterfall, but you've sort of it's got a design for test built into it. So when you're building your aircraft requirements and identification, you're also thinking about what you're going to do to test it. So you're planning on doing the verification while you're doing the planning and developing the requirements. Uh, and similarly, when you're doing your system requirements and then your item requirements, and then you're planning corresponding testing you're going to do for those later when you actually get it built. So you're doing design for test at each stage of the thing. But again, here also, this is still a long-term, multi-year probably process here. This is not a short-term turnaround here between these different stages here. Agile development processes have a different framework in them. They're adaptive, whereas waterfall is predictive. I mean, you think you know what you're going to do from the start, whereas adaptive says, let's do something and then find out how it worked and modify that. So here in this image here, you're working at iterations that are on the order of months, maybe long. Some agile processes use or frameworks use iterations that can be as short as a week. Uh, and the idea is that at each stage you try and have something built. And again, so you're trying to do rapid development and get working prototype, what's called minimum viable product, MVP, out at each stage here. It assumes the requirements are going to change. You don't assume that the customer knows everything about what they want. They may have a great idea, but that doesn't mean they've thought it through fully. And so you work with the customer, get them a working prototype very rapidly, and then they can say, oh, yeah, I like this, I don't like that. And then you can change as you go into the next phase. So it assumes the requirements are going to change. It adapts to changing requirements very easily with minimum investment. So again, the idea is to get minimum viable product out in short increments, and you stay in constant communication with the customer and the end user. There's several flavors of this. Maybe you've heard of Scrum. If you're in our department or taking some software engineering classes, you may have been exposed to Scrum. But there's others called extreme programming, which is sort of a team, a two-person programming effort. And then one called Crystal Clear, which is a lot like Scrum, but maybe a little less rigorous in terms of the stages it has to go through. And this can also be applied at the enterprise level, where you work. I mean, one of the flavors of Agile is it has small teams. You work in small teams, and so putting those teams together into teams of teams. There's several frameworks for that, and one is called SAFe, the Scaled Agile Framework. That's fairly popular. And then one of the Scrum developers, Jeff Sutherland, has what he's called Scrum at Scale, and has a very organized way of integrating between teams of teams. The teams of teams approach is widespread. General McChrystal, who was a commander in Iraq and during the response to the initial response to Al Qaeda in Iraq, really oversaw the transformation of the military operations there from a very static hierarchical framework into a very agile teams working together and different teams being able to trust that other teams are going to get done what they need to get done. So that, again, the concept of team, he got a book out called Teams of Teams. And it's very similar to the Scrum at Scale kind of framework. There's more about this. I want to share with you. I'll let you watch it separately. It's a TED Talk by my friend Joe Justice, and then I have some slides, and I'm going to do a separate recording for that about Scrum. We have a grant within the department from the National Science Foundation to investigate using Scrum in academic operations, and so we organize our department to use Scrum and to be a more agile department. And of course, that part of what Agile involves is listening to the quote customer uh, uh, or the end user. And in our case, I mean, the customer is students. The customer is also industry that hires our graduates. The customer is always also funding agencies that give us money to do research, alumni that are concerned about the university's well-being and their alma mater, etc. So I'll let you look at that stuff separately. I'll give you some links to those. Uh, what we did today, we looked at just very high level, 50,000 foot view of waterfall versus agile as far as development models go. And so we'll start talking in the next module about aerospace system certification and how do you do that design for safety and security.